यहाँ ध्यान से देख लीजिए। इस क्वेश्चन में एक यूनिफॉर्म रॉड है, फ्रिक्शनलेस वॉल पर हैंग लीन कर रही है और वॉल के साथ एंगल 60 डिग्री बना रहा है। अब कौन कौन सी फोर्सेस काम कर रही हैं ध्यान से देखेंगे। ये वेट ऑफ द रॉड है, और क्योंकि रॉड यहाँ पे रखी हुई है तो इसका एक, because rod is in equilibrium, therefore there will be a vertical force, that is the normal reaction. And because there should not be any vertical force, net vertical force नहीं होना चाहिए, net horizontal force भी नहीं होना चाहिए, तो net what will happen? Weight is acting in the downward direction, right? So normal reaction will act in the upward direction, and normal reaction should be equal to the weight because there is no friction in the wall. So this is also W. Then the wall will exert a normal reaction. This will be in this direction. This normal reaction of the wall, and because normal reaction is acting in this direction, and as the latter is in horizontal equilibrium also, so friction force will act in this direction. Okay, and force of friction will be equal to normal reaction of the wall. Okay, now for the rotational equilibrium, this is the initial thing we had to talk about, the various forces which are acting on the rod, looking at that the rod is both in rotational equilibrium as well as in translational equilibrium. Now, if we consider the sum of moments of the rod about point, let me call it as A, about point, let's say A, then W, that is the weight of the rod, is making it rotate in the anti-clockwise direction. About point A, we are taking about point A. About this particular point, W will make this rod move in the clockwise direction. And about point A, this NW, that is normal reaction of the wall, which is equal to force of friction, will make the rod move in the anti-clockwise direction. In the anti-clockwise. So W is in the clockwise, this is clockwise. And normal reaction of the wall is in the anti-clockwise direction. Okay. And because sum of moments about any point in the system is zero, therefore normal reaction of wall into, let me call it as BC, should be equal to W into, let me call it as M AM. W into AM is equal to NW into BC. Now, what is NW? NW is force of friction, equal to force of friction, and your BC is nothing but L cos 60 degree. W is 200 Newton, because weight of the rod is mass into acceleration due to gravity. And this AM is half of AC, which is L sine theta by 2. So this is L sine 60 degree divided by 2. So L gets cancelled. So this is F cos 60 is half, and this 2 gets simplified. And sine 60 is root 3 by 2. This 2 gets cancelled with this 2. So your F is equal to 100 root 3 Newton. So the force of friction is 100 root 3 Newton. इज इट क्लियर? सो इस क्वेश्चन में आपको ध्यान रखना था कि रॉड जो है वो रोटेशनल एंड ट्रांसलेशनल इक्विलिब्रियम दोनों में है। ठीक है, नेक्स्ट क्वेश्चन पर हम आते हैं। दिस इज अ सिंपल क्वेश्चन। आपके पास दो कंडक्टिंग स्फीयर्स हैं जिनका साइज नेग्लिजिबल माना गया है। दोनों के पास क्यू चार्ज है और इनके बीच में ओरिजिनली फोर्स एफ है। सो योर एफ इज इक्वल टू के क्यू स्क्वायर डिवाइडेड बाय आर स्क्वायर। अब आप एक थर्ड स्फीयर लेकर आते हैं, पहले उसको इसके साथ टच करते हैं। ठीक, तो सेपरेट करेंगे तो हमारे पास चार्ज क्या हो जाएगा, क्यू बाय 2 इसके पास रह जाएगा एंड क्यू बाय 2 इसके पास आ जाएगा, और ये क्यू है। नेक्स्ट आप इन दोनों को टच करते हैं तो फिर दोनों का टोटल चार्ज जो हो जाएगा वो बढ़ जाएगा। तो इसके पास भी 3q/4 चार्ज आ जाएगा, इसके पास भी फाइनली कितना आ जाएगा, 3q/4, because the spheres are all identical, so charges will get equally divided. So finally our situation is we have a charge of q by 2 and 3q/4 separated by the same distance r. तो अब की बार जो फोर्स हो जाएगी वो कितनी हो जाएगी, बिकॉज फोर्स इज प्रोपोर्शनल टू स्क्वायर ऑफ द चार्जेस, product of charges and inversely proportional to square of distance between them. So this is k 3q square by 8 r square. So this is 3 by 8. This is new force times old force. So 3 by 8 F. So the correct answer is second. This is a simple question.